Every year, more than 400 million tons of plastic are produced worldwide. It's everywhere, in bags, bottles, household appliances, tires, and practically everything around us. But how exactly is plastic made? Where does it come from? Today we're traveling to China, home to one of the world's largest plastic factories, capable of producing more than 10,000 tons of this material every day. Get ready, because we're going to discover how plastic is made step by step, and why it's the most ubiquitous material in our daily lives. The majority of plastic is made from petroleum, a thick, dark, and viscous liquid that formed millions of years ago. This petroleum comes from the fossilized remains of plants and marine microorganisms that accumulated at the bottom of oceans and lakes. Over time, these organic layers were covered by sediments, then compressed and heated by the Earth's crust until they transformed into crude oil. To access this resource hidden several kilometers below the surface, oil companies use enormous drilling rigs capable of penetrating rock and sedimentary layers down to the reservoir where the oil is located. These drilling rigs penetrate the Earth's crust and create a well through which the oil rises to the surface, pushed by the internal pressure of the reservoir or assisted by powerful pumps. The most impressive thing is that a single drilling rig can extract more than 10,000 barrels of oil per day, the equivalent of the raw material needed to produce approximately 400 tons of plastic. A colossal volume, but once extracted, this crude oil is far from ready for use. It's a highly complex mixture, laden with impurities and heavy compounds. Even though it has enormous economic value, it must first be refined before it can be transformed into fuel, plastics, and a multitude of other products. With the crude oil brought to the surface, it's time to transport it to the refineries, where its real transformation begins. Once extracted, the oil is transported to the refineries, via pipelines or enormous tankers, where it will be separated, purified, and processed. Crude oil arrives as a dark liquid full of impurities that is not directly usable for manufacturing plastics. It must be separated into different fractions. To do this, it is sent to large distillation columns where it is heated to temperatures of up to 400 degrees Celsius. Under the influence of heat, the petroleum vaporizes and the different components separate according to their boiling points. The heavier molecules remain at the bottom of the column, forming products such as heavy fuel oil or asphalt residues. The higher up the column one goes, the lighter the fractions become. Diesel, kerosene, gasoline, gas. Of all these fractions, the one that interests us for the manufacture of plastics is naphtha, a liquid located in the upper part of the column. Naphtha is a mixture of hydrocarbons that serves as a basis for petrochemicals. It is then sent to cracking units where it is heated to very high temperatures and sometimes under pressure in order to break these large molecules into smaller, simpler molecules like ethylene and propylene. These two molecules, and others of the same type, are the basic building blocks used to manufacture the main everyday plastics such as polyethylene and polypropylene. So we now have the essential molecules, but plastic does not yet exist in its solid form. The next step is polymerization, which transforms these small molecules into long chains. Now that we have ethylene, propylene, and other light hydrocarbons from cracking, it's time to turn them into plastic. This is where a fundamental process called polymerization comes into play. In simple terms, polymerization involves assembling small molecules called monomers to form very long chains, called polymers. In giant industrial reactors, monomers like ethylene are injected with special catalysts while precisely controlling the temperature and pressure. Under these conditions, the monomers bond to each other, creating long polyethylene chains. By changing the pressure, temperature, type of catalyst, or reaction time, plastics with very different properties can be obtained. For example, high-density polyethylene (LDP) is more rigid and resistant, used for containers, pipes, and caps. Low-density polyethylene, LDP, on the other hand, is more flexible and supple, perfect for plastic films, bags, and food packaging. At the end of this process, the plastic is not yet a finished object, but a viscous mass that will be transformed into granules, also called pellets, small cylinders or balls a few millimeters in size. These granules will then be melted and demolded to manufacture the products we use every day. And that's precisely what we're going to look at now. Once the polymer is obtained, it must be shaped to become a material that is easily transportable and processed. The plastic granules are fed into extruders, large machines equipped with a screw conveyor. Inside, the plastic is heated until it becomes a homogeneous and viscous paste. This paste is then forced through a die, an opening whose shape determines the semi-finished product. Tube, sheet, film, filament, this is what is called extrusion. Using this process, a single machine can produce more than 10 tons of plastic profiles, films, or sheaths per day. The production lines run continuously, sometimes 24 hours a day. Once extruded, the hot plastic is immediately cooled, usually by air or by immersion in cold water baths, to ensure it retains its exact shape. This results in film reels, bars, tubing, or reformed granules ready for shipment. To manufacture precise objects such as bottle caps, appliance housings, toys, or automotive parts, molding, primarily injection molding, is used. The principle is similar. Granules are melted and then injected at very high pressure into a steel or aluminum mold, machined with extreme precision. In just a few seconds, the plastic cools, hardens, and takes the exact shape of the mold. This extremely rapid process allows for the production of thousands of perfectly identical parts per hour. Once removed from the mold, the raw parts move on to the next stage, final cooling and cutting. When the plastic comes out of the mold or extruder, it is still hot and sometimes slightly deformable. Controlled cooling is therefore essential to ensure good dimensional stability. Depending on the type of product, this cooling can be achieved by immersion in water tanks maintained at around 10 degrees Celsius, by spraying with cold water, or simply by circulating air through cooling tunnels. Cooling time varies from a few seconds to several minutes depending on the thickness of the part and the type of plastic. Once completely solidified, the parts are ready for cutting. Even if they already have a general shape, they often need adjustments. Automatic cutting machines, equipped with blades, saws, or lasers, handle the cutting and deburring, removing excess material and separating the parts. These systems can process thousands of parts per hour while guaranteeing extremely precise dimensions. This phase is crucial to ensure that each product meets the specified tolerances, especially when it will be assembled with other components, such as housings, caps, or mechanical parts. Once this step is complete, the plastic objects have their final shape. Now it's time to give them their visual identity: color, logo, text, label. At this stage, many plastic products are still raw, often white, translucent, or a uniform color. To become recognizable and informative, they must be printed, decorated, and sometimes labeled. Specialized printing machines are used for this, capable of depositing ink on often irregular or cylindrical surfaces. For bottles, for example, screen printing is very common. A stencil allows ink to pass through only in the desired areas, creating the logo, text, and visuals. For other products, techniques such as tempography, digital printing, or hot stamping are used, which applies metallic or colored films using pressure and heat. In addition, regulations require the inclusion of certain mandatory information, such as the brand name, instructions for use, safety information, composition, volume, manufacturing or expiration date, recycling symbol, etc. Printing lines must therefore be both fast and extremely precise. Modern machines are capable of printing thousands of parts per hour, with perfect alignment and excellent ink adhesion to the plastic. At the end of this stage, the products have their final identity. They are no longer simply plastic parts, but objects ready to be sold and used. One last essential phase remains: packaging and distribution, so that these products can travel the world. Once the plastic products are fully finished, decorated, and inspected, they are sent to the packaging lines. Automatic machines group them into batches. This can be in bags, boxes, shrink-wrapped film, or cartons. The packaging systems operate at impressive speeds, capable of handling tens of thousands of items per day. The products are then placed on pallets, wrapped in protective film, and labeled with barcodes or RFID chips to allow for precise tracking of each batch. These pallets are loaded onto trucks, trains, or shipping containers, depending on their destination. Some raw plastics, such as granules, are sent to other factories to be processed into food packaging, electronic components, or automotive parts. Others, already in the form of finished products, are sent to logistics centers, supermarket warehouses, or food packaging plants. These plastic products are found absolutely everywhere: water bottles, snack wrappers, phone cases, toys, car parts, household appliances. Plastic has become ubiquitous in our daily lives. But behind this convenience lies an immense challenge. Every year, more than 52 million tons of plastic end up in the environment, disrupting ecosystems, threatening marine life, and potentially even entering the food chain in the form of microplastics. The same material that simplifies our lives is also one of the planet's major pollution problems. From its origins deep within the earth to store shelves, plastic is a material that relies on advanced technology, complex chemical processes, and a global logistical network. Now that you know the entire plastic manufacturing process, do you think this material remains essential to our daily lives? And in your opinion, who bears the greatest responsibility for plastic pollution? Industries, governments, or us, the consumers? Share your thoughts in the comments. The debate is open. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content.